Alright, so we'll go through the first few questions to make sure you're on the right track. So again, we're just applying Newton's second law, F equals ma. So the first question, what acceleration will result when a 12 Newton net force is applied to a 3 kilogram object? So you might just want to start by, we're finding acceleration, so we'll rearrange this equation. If we rearrange it, it becomes acceleration equals force over mass. You might just want to write the information they give you somewhere. They told us it was a 12 Newton force and the mass was 3 kilograms. So then it's just a matter of substituting the values in here, and you get 12 over 3, which is 4. The quantity that we're trying to find is acceleration, therefore the units will be meters per second squared. Now I said this a second ago, but the units will only be meters per second squared if force is in newtons and mass is in kilograms. Right, next one. If a 1,200 kilogram car accelerates at a rate of 3 meters per second squared, calculate the force supplied by the engine. So again, F equals ma. You might want to write that the mass was equal to 1,200 kilograms and the acceleration was equal to 3 meters per second squared. Therefore, F is equal to 1,200 times 3, which is equal to 3,600, and your units for force are newtons. Now remember, force is a vector and so is acceleration, so we should be giving a direction. So in this situation, you would be saying in the direction of movement of the car. So in the direction of the car's motion. Okay, next one. Sarah accelerates at 8 meters per second squared as she starts running. Alright, so that one's pretty much the same, but you just rearrange to find the mass. I want to do one that's slightly different, which is question 7. So in 7, they don't actually tell you the acceleration. A net force of 16 newtons causes a mass to accelerate from rest to 10 meters per second in 2 seconds. Determine the mass. So can you see how that one there, first you have to find the acceleration. They didn't just tell us the acceleration, they told us that the car goes from rest to 10 meters per second in 2 seconds. So do we know how to determine the acceleration in that situation? Acceleration is changing velocity over time. Once we know the acceleration, since we know the force, we'll be able to work out the mass. So I'll just do 7. Question 7. Acceleration is equal to change in velocity over change in time, which is final velocity minus initial velocity over time. Our final velocity is 10 meters per second. Our initial velocity is 0, happened over 2 seconds, so our acceleration is 5 meters per second squared. So now I've got my acceleration. Since they want me to determine the mass, remember force is equal to mass times acceleration, therefore mass is equal to, you have to rearrange this, you bring A to the bottom, so m will be equal to F over A. Do I know what the force acting on the car is? They told me it was 16 newtons, so it'll be 16 over the acceleration, which is 5. So 16 over 5 is 3.2, and my units for mass, kilograms. So in question 8, they say a car's accelerating at 2 meters per second squared. If the net force is tripled, what's the car's new acceleration? Now this question requires us to use proportionality. So what does that mean? If I have a look at Newton's second law, F equals ma. So they said that the car, so if the force is tripled, what is going to happen is the acceleration is going to be tripled as well. The reason why that is force is directly proportional to acceleration. So, and I'll give you an example. Let's just say that we've got some mass which is 10 kilograms. All right, the mass is 10 kilograms, and our initial acceleration is 2 meters per second squared. All right, so if I wanted to find the force here, F is equal to mass times acceleration, which is 10 times 2, which is equal to 20 newtons. Now, if I triple this initial acceleration, and go 3 times 2, so that would be tripling it, can you see that the force will also be tripled? All right, so let's have a look. So we'll use the same mass. So this is the initial force. That's the initial force. If I do 3 times the initial force, that would be, 3 times the initial acceleration would be 6 meters per second squared. So now if I find out 3 times that initial force, let's have a look. It's going to be 10 times 6, which is equal to 60 newtons. So see when I tripled the acceleration, how the force also tripled? Alright, and it's vice versa. The same thing works the other way around. If I triple the force, the acceleration will be tripled. If the acceleration's tripled, then the force would be tripled. So with this question, it says if the net force is tripled, what happens to the car's acceleration? The acceleration would also be tripled, so that 2 meters per second squared becomes 6 meters per second squared. That's what we call proportionality. Alright, so force is directly proportional to acceleration. So I'm just going to go through question 9 with a diagram. So what acceleration will result when a 12 Newton force is applied to a 5 kilogram object that experiences a force of friction of 5 newtons? So if I was given that type of question in a test, I would be drawing a diagram. So here's my object. Its mass is 5 kilograms. Now it's got a force going forwards of 12 newtons. So that force there equals 12 newtons. And then there's a frictional force, which is equal to 5 newtons. So now I've got a very clear diagram of what's happening. I'd be writing net force. Net force. What does net force mean? It means the total force is going to be, now since these are in the same plane but in opposite direction, we can just subtract one vector from the other. I can just go 12 newtons minus 5 newtons. If one was pointing up and one was pointing that way, I can't just subtract vectors like that. But because friction's acting in the same direction as the force of the object, I can do that. So the net force is going to be 12 minus 5, which is equal to 7 newtons. So now I know the force, I know the mass. They wanted me to work out the acceleration. Again, F equals m times a, therefore a equals F over m. Our net force was 7 newtons. Our mass was 5 kilograms. Therefore our acceleration is 1.4 meters per second squared. Always remember your units. Again, because acceleration is a vector, we should be stating a direction. So to the right of the page. To the right of the page. In year 10, I probably won't be too harsh in a test if you didn't give a direction, but in year 11 physics, you definitely have to be giving directions for vector quantities, so you may as well just get used to doing it now.